In HVAC industry, refrigerants are very important. First of all, we will see what is a refrigerant. So, what's composition it is, and in what way they are very important in an HVAC industry. So, we are going to discuss everything in detail in this today's session. So, refrigerants, without a refrigeration, there is no HVAC industry. So, how this refrigerant is contributing in HVAC industries, and what are the different types and categories it will be divided into further. So, these things can be today we are going to discuss. So, guys, you try to have an overview of refrigerants after completion of my this session. I mean, so you can have a look out to different books and those kind of things, how the refrigerants are being contributed to the HVAC industries and what are different types and what is GWP, as well as what is an ODP, the ozone depletion potential. So what's its impact on further releasing of these gases to the atmosphere. So these are the things we are going to discuss. So refrigerant is one of the liquid which is a combination of gas and an oil. So you know, guys, in an copper tube, the refrigerant is completely circulating along with the mineral oil as well as the gas. So both should be what I can say, miscible, mixing each other, so that the flow should not be in an intermittent kind of things. So it should be flowing in a what you say, homogeneous way, so that it should work as a compressing agent as well as to capture the heat from the indoor space, as well as simultaneous the oil which is also circulating along with the refrigerant, it also should be need to what you say, service or give the lubrication to all the parts, maybe it's a scroll compressor or a piston type or any other kind of things, because mineral oil is one which is going to lubricate this particular points inside the compressor. Now we can see here in a refrigerants how important it is. These are also classified into different categories. So firstly you can see here CFCs, that is chlorofluorocarbons. Here CFCs, there is a composite fluorine, chlorine and carbon. Fluorine, chlorine, carbon atoms are present in this one. In this category you can see CFC 11, 12 as well as CFCs 114. The more familiar one is R11 and R12, R114. This R12 has been previously used in the refrigeration industry in case of mobility in the a railway industry, but nowadays due to its ozone potential, due to heavy and which is damaging the ozone, so this has been phased out and has been replaced with the some other refrigerants. So I am going to explain you in detail what are the things which has been replaced with R12 and all. Coming to next category is hydrochlorofluorocarbons. These are HFCs. These are composed of hydrocarbon atoms as well as chlorine, fluorine and carbon. Again it is present here. So in this category you can see HCFC is 22, that is nothing but R22 and R123, and HFC 123 is nothing but R123s. Coming to third category, HFCs, these are also composed of hydrogen, fluorine, carbon atoms. So in this one you can see HFC 134A as well as it can be represented as 134A as well as HFCs 125 or 125. So R is nothing but it is a refrigerant name convention. So there are also other mixtures. We can divide into two categories. They are azeotropies and blends, or nothing but zeotropies. The blends also can be renamed with zerotropies. So what are azeotropies and blends? Azeotropies, the mixtures, these are the mixtures of refrigerants, behave as a single substances in all conditions. So they try to mix as a single entity and behaves as a single entity. In case of, you can take an example, it evaporates and condensation in evaporation is happening at an same conditions. These in this category you can see are 500 CFCs and HCFCs. So coming to zeotypes are the mixture. They don't behave as a single substance. Even they do not may evaporate or condense at a constant temperature. So their operating pressures, temperatures are a little bit complicated and related to some services problems also. So I think you understood about azeotypes and blends. Blends are nothing but zerotypes. Okay, azeotypes explains this behaves as a single substance and zeotypes behaves as a different substance. So coming to the properties of a good refrigerant. So what are the properties needed for a good refrigerant to be selected? So what are the properties it need to be selected, and we need to put in an air conditioning machine so that our efficiency will be good. So let me show all the things, you can have a look. So good properties of a refrigerants: the temperature properties, pressure, oil mixing, the mixing of gas and oil. This is the mixing always. I told the mixable and miscible property with oil and gas. It should behave as a single one. It should not behave as a separate one, because due to high pressure and temperature, if the oil is separately, it's behaving, as well as the mixing probabilities are not there, and if they don't are mixing in a single manner, the gas pressure will be raising separately and the oil will be sitting as a sludge kind of things, which is not a good sign for the refrigerant. So heat transfer possibility, heat specific heat, non-toxic, means it should not be poisonous whenever it is leaked inside an space of the people where they are living. So it should not damage the conditions. And stable, it should be stable and inexpensive. It should not be cost also. So there is here one point is missing, which I need to say, that is global warming potential, GWP. This is also one of the important property of a refrigerant it should have. So GWP, global warming potential, I will be coming in further and I will explaining that one. Generally it should have a low global warming potential. To coming in further things, I want to explain you how basically it's damaging the ozone layer. See, one chlorine atom is going to damage 10,000 ozone molecules. This is the potential damage factor a chlorine atom is having. So instantly scientists have did lot of research and they found lot of ways how to phase out this particular chlorine atom. So then came some of the few refrigerants with phasing out chlorine as an atom. So this were mainly invented because or developed because to protect the ozone layer. Already it's getting damaged. So there comes a concept called ozone depletion potential, ODP. The ODP is nothing but ozone depletion potential. Generally, if ozone depletion potential is 1, it is going to damage perfectly the ozone layer, as I said, and because it will be consisting of a chlorine atom. Coming to CFCs 11 and all, see, it's already 1, and CFC 12 is also having 1. That's why I said railway industry was using earlier CFC 12, which was phased out because of the norms, and now they are using R32 kind of refrigerants. So HFCs, you can see 134, it's having 0. It represents it's a 0 ozone depletion potential, means it is not going to harm the further environment as well as the ozone layer. See, these are the different representation of colors of the gases. You can see here each color of gas is having different colors. See here R11, R12, R13 and 131B, R113, R1114, 500 and 22. So many are there, gases are there. So you can see here these are the types of color things. So CFCs are represented in this area. So you can see what are the present under the CFCs and what are the present under the HCFCs. And HCFCs also further here given here. HCFCs is given here, and HCFCs, only HFCs are present here. So let me take you to further things here. Here coming to the global warming potential of the refrigerants. So you can see there are different refrigerants represented by R32, R22, R134A, R407C, R40A and R417A. So you can see the global warming potential of this particular refrigerants. So I want to say before that, what is in global warming potential? It is the index to measure how much of thermal radiation the greenhouse gases would be capturing or absorbing over a time frame. So the capacity of the greenhouse gases, it is having ability to absorb, that is called global warming potential. So coming to refrigerants, R32 is having the global warming potential which is 675, and R22 is having 1700, R134A is having 1300, R407 is having 1610, R410 is having 1890, R417 is having 2340. Guys, you can see R417A is having high global warming potential. So this reference, this is not suitable and it is going to absorb most of the heat compared to the R32, which is having lower global warming potential, which you need to understand. Here you can see the chlorofluorocarbons, CFCs, and hydrofluorocarbons, HFCs, hydrochlorofluorocarbons, HCFCs, as well as fluorocarbons, PFCs, and sulfurohexafluoride SF6 are sometimes having high GWP gases for a given amount of mass, how much heat they are going to trap, more than the CO2. This is the thing. So these are having high GWP values. So coming to HFCs 32. So HFC 32 is a good refrigerant. I said already it is having low GWP and it's also having high efficiency. High efficiency means it's having the heat capturing rate from the indoor space, the absorption. Coming to the refrigerant R407C is a blend. It's a blend of R32, this one, and R125 refrigerant and R134A refrigerant in the portions of 23%, 25% and 52%. See, I mean the 32 is, R32 is in 23%, 125 is in 25% and 134A is in 52%. So this is called a blend. So this particular R407 is called a blend. So try to understand what are blends. I already told. See, generally the R32 have, or not only R32, every refrigerant have these parameters. The boiling temperature, at what temperature this refrigerant is going to boil, and critical temperature, critical pressure, global warming potential and ozone depletion potential. See, 0 here is giving, and GWP, that is 675. So critical pressure they have given already, critical temperature they have given already, and ASHRAE safety group. So what is an ASHRAE safety group? So A to L, this is the safety factor which is given to the refrigerant. So according to the ASHRAE standards, we need to refer these documents, the design and safety classification of refrigerants. So I can show you here. Higher flammability safety groups A3, B3 they have given. Again you can see here the lower toxicity and higher toxicity. So we can see our refrigerant, this particular A to L, it's in a R32 in the category of A to L. It is in A to L is in a lower toxicity. Okay, so this is how you need to have an close look in the safety group. So A to L, it is in lower toxicity. Suppose if it is in a B to L, it will be having a higher toxicity. That is a safety group. I told already it is included in ATL category. So guys, you please refer to the design and safety classification of refrigerants document from ASHRAE. Sometimes you can see these also properties are required. The surface of the coil dry, airflow and capacity, air temperature, leaving air temperature, air pressure, tube side temperature, that is condenser side, hot gas temperature and subcooling in degrees. So these are all technical parameters related to tubes. Coming to SCFM, that is a standard cubic feet per minute of air. That is a molar flow rate of the gas expressed in the standard temperature and pressure. The flow rate of gas expressed in standard temperature and pressure, which is known as SCFM, standard cubic feet per minute. So this standard cubic feet per minute is based on the ideal temperature and pressure, while CFM is the actual flow of air. So you try to have a difference between SCFM and CFM. So this is very important. You try to have a good understanding of these things. So you can see the image how it is. So US greenhouse gas pollution indicates, see, 82% of carbon dioxide is present here and 9% of methane is there, 6% of nitrous oxide and 3% fluorinated gases. How these are being contributed by transportation, agriculture, industry, commercial and electricity. This is a just representation to understand how much of this greenhouse gases are being contributed to the atmosphere, which in turn is the global warming is increasing. So what we need to understand from this. So water vapor is also another greenhouse gas. How? If the more water vapor is present in the air, it will be having the heat capturing capability, because it tries to increase the heat, more moisture is present and it will have more heating capability. So in this manner it is trying to hold heat as well as water as well as heat. So that's why you can say the water vapor is also another greenhouse gas.